Hey everybody, let's look at 56, which are finite and infinite sets. And just as a matter of housekeeping, a set is basically just a group of numbers. It could be, all even numbers, or it could be all negative numbers, or it could be zero, or it could be empty. I mean, the number of numbers, that are greater than 10 and also less than 5. Well, nothing exists, so that wouldn't be anything in that set. But this is what indicates a set, these kind of fancy looking brackets. Practice drawing those things are not exactly easy, but a finite set is something like this that you might say, oh, the integers between 0 and +6, that might be a finite set of numbers. If that's the case, then there they are. I just list them for you. Now, an infinite set, it'd be something like this, the same kind of thing. They might say all positive integers. Give me the set. And of course, no human on earth can ever write even close to being all the positive integers. It's not possible, even if you write really fast. You just can't do it. So what you do is you go, okay, 1, 2, 3, 4, 5. You could even just do like 1, 2, 3, and without even these two, and you just put an ellipsis there, which indicates we're just going to keep going on forever. Okay, and you'll see things like this. Let's just do this example. Represent the following numbers as being members of set K, and then there's the group of numbers. Well, you go, okay, here are the numbers. You could go, okay, K. Usually they have like the in a capital letter, and they also have it italicized to indicate that it's a set. Okay, so K. Then you can go your little sets of parentheses, or your kind of brackety looking things here. Well, let's go from the lowest to the highest here. So I'll go 0 is a member. You can just put it once if you want. 1 is a member of the set. Where are we at here? 2, that's a member. Okay, we got what, 4? Okay, there's a 5 in there, and there's a 7 in there. Okay, there we go. And that's how you could just represent set K. Do it like that. Okay, that's a finite set. There isn't an infinite number of numbers in that. There they are right there. Okay, here's a second one, set L. Now look at all these numbers. Okay, well, you do the same thing. Your italicized capital L, and you put the little fancy bracket, and then I'll try to go least to greatest again. What is that, -13? Okay, there we go. And what we got, 0 here. I got zeros. And then there's a 1. And then what we got here next? Probably 7, and then 8, 7, 8, and then there's a 15. There we go. And then the last one's 42. And there's your set L. Boom. All right. Okay. There's another symbol, or two symbols you're going to look at. The symbol on the left means that a number or an item is a part of a set. Obviously, the one on the right means that there is something that is not part of a set. And they're going to pull these little logic problems for you. They're pretty straightforward, but you'll see what I mean in a second here. But here is set L again, and there are the members of the set L. Okay, and here's a way we can say. Now look at this one first. We can say 0 is a member of set L. Okay, there it is. Okay, we can also make another statement. 23 is not a member of set L, because it isn't. It doesn't show up in the list of terms that are in that set. Okay, members of the set. All right, they'll give you problems like this. Given these sets, in other words, here are your sets. Okay, are these statements to the right here true or false? All right, let's take a look at one of them. 5, in other words, 5 is a member of set A. Is that true or false? Well, look over at set A. Does it have 5 as a member? Yes, so that's true. All right. All right, the second one. 4 is a member of set C. Well, is 4 a member of set C? Look at set C. No, that's false. All right. Well, look at this one. Is 5 not a member of set B? Well, 5 is not a member of set B. Let's see. Do you see a 5 in there? Not in there. Okay. So this is also a true statement, because 5 is not a member of set B. Okay. Okay, let's try another one. Given these sets, and these are your 3 sets, are these statements true or false? Well, first off, let's look at this one. 6 is a member of set L. Well, it isn't, so that's a false. Okay, so the second one is 0 is a member of set N. Well, there it is. That one's actually a true one. So, yeah, pretty straightforward, these. Okay. All right, the second part of 56 is rearranging before graphing. Before we do all this, you need a piece of graph paper. And if you've got a ruler, it'd be nice to have something you can draw a straight line with. But let's go back and talk about graphing. And let's look at this line. And you are going to graph this line here. And we're going to remember what it means as far as, remember the old ideas we have with trash cans and babysitting and that kind of thing. Let's put this into practical terms here, I guess, okay? Let's say, for example, you get hired to babysit a bunch of kids for I don't know, let's say a bunch of homeschool moms want to go to Hobby Lobby and like stare at everything for 12 hours one day. So they go, we'd love for you to babysit our kids for 5 hours while we're at Hobby Lobby. So here's what we're going to do. We're going to charge you $1. We're going to charge you $1 to rent the room or whatever. But we'll also, even though we charge you $1 to rent the room, for every kid that comes, we'll pay you $2 that you watch. Okay. Okay. Or it could be maybe it's it costs $1 for them to buy a giant slug of NyQuil for all the rowdy kids. So you have to pay $1 for us to get the NyQuil for you to put them all to sleep. But for every kid you babysit, we'll give you $2. Okay, let's do that. And if you recall, you could just plot points. In other words, you could go, obviously in this case, X represents the number of kids you're going to babysit, because you don't know how much money you're going to make until you know how many kids show up, right? So $2 per kid, okay? The easiest one always to use is that no kids show up, right? Or 0 for the X. So if no kids show up, in other words, the X is 0, what's the value of Y? In other words, the money you're going to make is Y. So it's going to be 2 times 0, which is 0, minus 1, boom. And that's 1 point, right? 0, negative 1. So 0, and then thunk, right there. There's your point, okay? Let's say, I don't know, let's say 2 kids show up. How much money are you going to make? 2 kids show up, you get $2 per kid, but they charge $1 for the NyQuil to put them all to sleep. Okay, you get $4, right, for the kids, but you have to pay for the NyQuil, so that's $1 for the 3. So there's another point, right? 2, 3. So this is the X, and this is the Y. In other words, this is the kids, this is the money you make. So 2 kids, you go 1, 2, 3. That's how much money, right? Oops, got a little bit too much of that there. Okay, let's say, I don't know, you did 3 kids. All right, if you do 3 kids, you tell me how much money you're going to make. $2 a kid minus the NyQuil. Okay, so you make $6 minus 1, 5. So there's your third point. It's nice to do 3 points so you can make sure you didn't make a mistake. So 3 kids, 1, 2, 3, 4, 5. And then there's your line. That's what your line's going to look like as long as you hit that's why you need a ruler. I stink at drawing straight lines. Okay, all right. But we're used to seeing y equals blah, blah, x plus 3 or minus 1 or whatever it is, okay? Sometimes you're going to get equations like this that don't look nice and clean like this. Your job is going to have to be to shove the y over to the left side, positive 1y, and everything else goes over to the right. Make your x come first, and you make your number come after that. So in other words, you'll see something like this. So go ahead and take a second and copy this down. Okay, this doesn't look like, y equals, they call it mx plus b, or the slope times x plus the y-intercept. But there's not like a certain kind of x plus a number. The x is over here. It's just all out of order. So what we're going to need to do is we're going to need to move this 3x over here. Now you know the rule of that, okay? When we do that, the 2y is the only thing left to the left, okay? If you move the 3x over, that changes the sign of that, so it's negative 3x and it's plus 4, right? Don't forget that's a plus 4, okay? This is looking better. You see how this is kind of looking close to this? Okay, there's only one last thing we have to do to make this equation look just like this, and there's your clue right there. What do we need to do to the entire thing to make it to where it's 1y? I have to divide by 2, right? Okay, so in other words, we divide by 2, divide by 2, divide by 2. Okay, so a new equation becomes 2 divided by 2y, or just y, and negative 3 divided by 2, just put negative 3 over 2. That's fine to put. and x. There's nothing wrong with having a fraction in front of the x, totally fine. 4 divided by 2 we know is 2. Okay, that is your equation. There you go. Now we're going to need to graph that. In other words, think about what this means. Okay, how much do you get for just, let's say it's babysitting. Okay, how much do you get for just showing up? You get $2, right? Okay, this is a weird. They're going to charge you because it's negative 3/2 of a dollar for each kid that shows up. So you better not let any kids show up, or you're going to be losing money. Okay, so you need to like beat them away with sticks at the door. Okay. Anyway, we're going to do the same old thing we did in the last time. We're going to plot points here and go boop. There we go, and see what we get. Use a 0. That's always the easiest thing, because what ends up happening is if no kids show up, how much money do you make? You make $2. There's your first point, right? 0 over and then 2 up. There's the first point, right? Okay. Now look at this thing. This x, the number by the x has a fraction of it. There's a 2 in the denominator. That is your clue to put multiples of 2 as possibilities for y. In other words, don't put a 1 in here. Don't put a 3. Put a multiple of that, of 2. So I'd use a 2, and then I'd use a 4. Okay, so let's work on this point, the second point next. If 2 kids show up, that's going to cost you. In other words, you're going to go -3/2 times 2 kids, right? So these 2's cross out. -3 divided by 1 is -3, right? It's going to cost you $3 for these kids to show up, which is a bad deal. But you also get paid $2, right? So -3 plus 2 is -1. So that's your second point. So 2 over, and then there you go. 2 and then -1. Oops, did too much of a, there you go. Okay. All right. If 4 kids show up, well, this is even worse for you. The more kids that show up, the worse it is for you. If they're charging you $1.50 per kid, and you go, okay, if 4 kids show up, then -3, and if you just want to not cross off, just leave the 2 there. -3 times 4 is -12. -12 divided by 2 is -6. So they're going to go, okay, cough up $6 to us. You're going to go, oh, here's $6. And then they go, oh, good news. You also get 2 for showing up. So here's 2 of your dollars back. But obviously you were still out $4, right? So you're at -4. So 4 kids show up, you get -4. So 1, 2, 3, 4, and then 1, 2, 3, 4, and that is your line. Ooh, I hit all 3 of those dots. That's your line. There you go. So the point is, when that equation looks like that, move everything around so you have a positive 1y on the left side and everything else on the right side, okay? Here's another one. Take a second and copy this down. Okay, it's y minus x equals 0. Well, there's only one thing we have to mess with now, right? The negative x is on the wrong side. So all you do is you go, okay, I'm moving this over to that side. Or if you want to think of it this way, I'm adding x and I'm adding x, right? My new equation, y equals x. If you want to put plus 0, you can. Doesn't matter. You don't have to put anything there. Okay? Well, you tell me the setup here. And don't forget this is 1x, right? If there's anything written there, it's 1x. They say to you, oh, well, you don't get paid anything at all to show up. Nothing. But let's say it's your dad and you're working outside. For every trash bag you fill with leaves, you get $1. I hope they're small trash bags. Okay. So obviously, if you fill up 10 trash bags, you get $10. That's pretty simple to figure out, right? So let's do the old, putting in stuff and seeing how much we get. Obviously, again, 0 is so easy to use. If no trash bags you empty or fill up, you get no money. So 0 and 0, that's your first point. Well, that's right there, 0, 0, right? Okay. Well, if you do 3 trash bags, that's going to be 1 times 3. $3 plus 0 is $3. So 1, 2, 3, 1, 2, 3. There's your second point. Not filled in. Oop, not quite. There it is. Nope. Good enough. Look at that. Hold up. Okay. Let's say you did, I don't know, 5 or something. Obviously, you get $5, right? So over 5 and then up, and then there you go. Okay. So the point is, there's your line. Okay. But you had to just move that thing over. In other words, your equation of the line needs to look like this. Y equals something, so I'll just call it m, some number in front of the x plus some number. I'll call it b. Okay, the number could be 0, could be 1, could be -5, could be 2, whatever. And that's what you're trying to do. Okay, well, pause it and go ahead and let's try the practice problems. And go ahead and try A, and then we'll unpause it and do it. Okay, I'm assuming you're finished. Set K, a little bit of slant there to make it in italics, that equals. Okay, what do we got here? Zeros first. We got a 1. We got a 3. We got a 5. And we got a, there's another 5. Okay, and a 9, and there you go. Fancy brackets. Okay. Pause it and try B. Okay, well, let's look at it. Let's answer these questions. Here are the sets. Are these statements true or false? Let's go this one first. Is 5 a member of set B? We'll look at it. Yes, it is. True. All right, done. All right, is 5 not a member of set C? Is that true? Well, is 5 a member of set C? The answer is no. So if they ask us, is 5 not a member of set C? That's also true. Okay. All right. For C, or for the third one, 0 is a member of set A. Well, is 0 a member of set A? Yes, it is. Okay. All right. And the fourth one, is 3 not a member of set C? Well, no, 3 is a member of set C. So this is a false statement. False. Okay. Okay, pause it and try C. All right. Let's go to C. And this is a tricky one, but don't forget your idea is to make your graph look like this. Y equals some number times x plus an actual number. Okay. Right now, this is all goofed up. First off, we have a negative y. We have a -3 in front of the y. The x is in the wrong spot. You know, it's a mess. But we can do this. We just move let's just do one step at a time, okay? So we move the 2x. In other words, we'll subtract the 2x from both sides. All right, let's do our new equation. So we got -3y on the left. We got -2x on the right, and this is going to be +6 because that's just a normal 6. Okay. The last thing we need to do is this doesn't look right. There shouldn't be a -3 in front of that y. There just should be a y, positive y. Well, how do we turn -3y into positive 1y? We're going to have to divide everything by -3, right? It's an equation. So everything you do to the equation, you do to every part of the equation. Okay. There. So -3 divided by -3 is just 1. So we have our 1y. Good. Okay. Actually, I like when this happens. We have a -2 divided by a -3. Well, a negative divided by a negative is a positive. Okay. X. Then we have a +6 divided by -3 is -2. Okay. All right. Babysitter situation. You tell me. Look at that equation. Y equals 2/3 x minus 2. What's in it for you as the babysitter of a bunch of screaming brat homeschooled kids? How much do they charge you to rent the room, let's say? Oh, we got a room at a church. How much do they charge you to rent the room? $2, right? So they're going to charge you $2 just to show up. $2, okay? For each kid, how much of a dollar do you get? 2/3 of a dollar, right? Okay. So that's your setup. You know, I mean, the more kids you babysit, the more it'll be for you. So that's, not too bad, actually. Okay. So let's do the setup. Let's just plop in some numbers and see how much money you're going to make. All right. So again, always do 0 for x. It's so easy. No kids show up, bad for you, right? Because it's going to cost you $2. So there's one of your points. In other words, if you're looking at this graph and going, oh, how much money going to make? Okay, this is the number of kids, right? That's the x. The y is the money you're going to make. Oh, good. No kids show up. Yeah. You go, ugh, this isn't good for me. I make -$2. Blech. Okay, forget it. I don't want that. Okay, and don't forget, since this right here has a 3 in the denominator. You need to make sure that the numbers you choose in your little setup here are also multiples of 3. So let's make them multiples of 3. It could be anything. It could be 3, 6, 9, 12, 15. It doesn't matter. They'll all work if you do it right. So don't worry about choosing the right numbers. Although, again, I would look at that denominator and go, if there's a 4 on the bottom, you better choose 4, 8, 12, and so on. If there's a 5 on the bottom, you better choose 5, 10, and all that kind of jazz. Okay, but there's a 3. Let's just try, let's just say 6 kids show up. And let's also try, I don't know, we'll try 9 kids, okay? So let's figure out what this is. You tell me, okay? 6 kids show up, all right? So you're going to have to go, the X is the kids, right? So you're going to need to go down here and go, okay, 2/3 of 6. 6 kids, plus minus $2 for your rent in the room, okay? Well, 2/3 of 6, you can do the old math here. You can cross that out. That's going to be 2, right? So 2 times 2 here is 4. Hey, I made $4. Oh wait, minus $2 to rent the room. Okay, so 6. So if 6 kids show up, 1, 2, 3, 4, 5, 6 kids show up, and you get $2. Yeah, I'm not sure I'd work an hour with 6 kids for $2. Well, anyway, okay. Let's say 9 kids show up. All right. Well, you tell me. 9 kids show up, that's the kid. Okay, so we got 9, we'll call it over 1, of course, okay? Well, 2 times 9 is 18. 18 divided by 3 is 6. So you just made $6. Oh, excuse me. Yeah, you know what? I think I made some mistake here. 4. Oh, hold on a second. Let me try this again. Here's my equation. I think I goofed a tiny bit. Bear with me 1 second here. Okay. So y is 2/3 x minus 2. If I had 6 kids, yeah, I guess that's right. Okay, we were right. That's going to be a 6 and a 2. If I made 9, I had 9 kids. Okay, that's correct. We got it right. Okay. So if you had 9 kids and you did the arithmetic, you go, hey, 2/3 times 9 kids, right? Well, that'd be 18 divided by 3 is 6, but you'd subtract 2, so 6 minus 2 is 4. So if you had 9 kids show up, you'd make $4. Oof, that's rough work anyway. But if we can go over here and go, okay, 9 kids, 1, 2, 3, 4, and that's how the graph looks. And there you go. Okay. All right. We eventually got that one right. So anyway, okay. Have a great day. See you next time.